Welcome to the Daily Globe. Please subscribe and hit the bell icon for more breaking updates. In the world of modern infrastructure, a quiet revolution is underway, led not by workers, but by autonomous machines. These machines, guided by advanced algorithms and artificial intelligence, are transforming the very foundation of how we build our cities, roads, and bridges. Where once the sound of hammers and shouts of workers filled the air, now the hum of electric motors and the precision of robotic arms dominate the landscape. In October 2024, China unveiled a 165-kilometer stretch of the Beijing-Hong Kong Expressway, built almost entirely by robots. This monumental project stands as a testament to the nation's commitment to technological innovation and efficiency. The expressway, stretching across vast rural landscapes, was constructed with minimal human intervention, relying on fleets of self-driving trucks, automated pavers, and intelligent quality control systems. This is no sci-fi fantasy, it's a concrete reality reshaping the Chinese countryside. The sight of robots pouring concrete and assembling infrastructure, once the stuff of futuristic dreams, is now an everyday occurrence on these sites. The efficiency and precision of these machines have set new standards for what's possible in large-scale construction. The project signals a seismic shift, challenging the long-held belief that construction must be labor-intensive. For decades, roadwork has been synonymous with backbreaking labor and long hours under the sun. Now, with robots taking on the most demanding tasks, the industry is being forced to rethink its very identity. Automation, which transformed manufacturing, is now conquering construction, one of the last human-dominated frontiers. The same principles that revolutionized car factories are now being applied to the world's largest building projects, promising not just speed, but also consistency and safety. The world is watching, as the lessons from this highway could soon be applied globally. Governments and companies from every continent are studying China's approach, eager to replicate its successes and avoid its pitfalls. The implications stretch far beyond a single road. They point to a future where infrastructure can be built faster, cheaper, and with fewer errors. China's achievement promises faster, higher quality, and more cost-effective infrastructure. The roads built by robots are not only completed in record time, but also exhibit a level of uniformity and durability that is difficult to achieve with traditional methods. This could mean fewer potholes, less maintenance, and safer journeys for millions. But it also raises tough questions. What happens to millions of construction workers? As machines take over more tasks, the livelihoods of countless people are at stake. The transition to automation could bring about social and economic challenges that must be addressed with care and foresight. How do we ensure the safety of machine-built infrastructure? As robots take on more responsibility, rigorous testing and oversight become essential. Engineers and regulators must work together to guarantee that these new roads meet the highest standards of safety and reliability. This 165-kilometer road is not an endpoint, but the start of a global conversation about the future of work and technology. It's a symbol of what's possible when innovation meets ambition, and a reminder that the choices we make today will shape the world for generations to come. The story of the robot-built highway is a story of progress, disruption, and the dawn of a new era. As we stand at the crossroads of tradition and technology, the path we choose will define not just how we build, but how we live, work, and connect in the decades ahead. The robot-built highway is more than just a marvel of engineering. It's a symbol of China's bold vision for the future. Here, machines and humans work side by side, transforming ambitious blueprints into reality at a scale and speed never seen before. This achievement is the result of China's deliberate and strategic push to lead the world in robotics and artificial intelligence, fields that are rapidly reshaping global industries. In 2023, the government announced a sweeping policy, setting aggressive targets for the mass production of humanoid robots, aiming to make them a common sight in factories, warehouses, and even public spaces. At the same time, China is working to secure its domestic supply chains, ensuring that the core technologies and components needed for this robotic revolution are developed and manufactured at home. Public demonstrations, such as the world's first humanoid robot half-marathon, have captured global attention, showcasing just how quickly these technologies are advancing and how seamlessly they can be integrated into everyday life. Real-world tests of autonomous vehicles on these new highways have revealed both remarkable breakthroughs in self-driving technology and ongoing challenges, pushing engineers and researchers to innovate even further and refine their designs for safety and efficiency. Underpinning this drive is a shrinking workforce, as China faces demographic changes that threaten its traditional manufacturing strength. There's also a strong desire to move up the global value chain, shifting from low-cost manufacturing to high-tech innovation and advanced production. At the heart of this transformation is the need for technological independence, so China can control its own destiny in a rapidly changing world. By fostering deep collaboration between state enterprises, private tech giants, and research institutions, China has built a powerful innovation ecosystem that accelerates progress and turns ambitious goals into reality. The 165-kilometer highway stands as the flagship achievement of this national strategy, a living testament to China's grand design for a future powered by robotics, artificial intelligence, and relentless innovation. The expressway's construction began with data, not shovels. Drones mapped the entire route, creating a detailed digital twin that served as the project's master blueprint. Sophisticated algorithms coordinated a fleet of autonomous machines, optimizing every phase of construction. Machines worked around the clock, rerouting and adjusting in real time to maintain momentum. Sensors on vehicles provided constant feedback, allowing micro-adjustments for perfect quality. Human oversight shifted from manual labor to technical supervision in a central control room. Technicians monitored the operation, intervening only when necessary. This project redefined construction work, turning workers into high-tech supervisors. Specialized machines were the stars of the site. Autonomous trucks and pavers laid the foundation with unmatched precision, guided by GPS and digital plans. Robotic rollers, equipped with advanced sensors, compacted materials to exact specifications, ensuring durability. Drones provided real-time aerial data, enabling instant quality control and corrections. The seamless collaboration between machines created a continuous, efficient production line. Manual inspections and rework were drastically reduced. The result, 165 kilometers of expressway completed at record speed and quality. This was construction transformed into a data-driven industrial process. The automated highway's results were striking. The road's uniformity and durability surpassed conventional standards, promising a longer lifespan and lower maintenance costs. Continuous, optimized work slashed construction time, setting a new benchmark for speed and efficiency. Material use was precisely calculated, minimizing waste and environmental impact. The project required only a small crew of technicians, replacing the usual army of laborers. This shift provides concrete evidence of automation's disruptive impact on construction jobs. The highway stands as proof that automation can deliver superior infrastructure with fewer resources. The robot-built highway raises a critical question. What happens to the workers? Automation threatens millions of construction jobs, replacing manual labor with machines. The economic logic is clear: lower costs, fewer accidents, and round-the-clock work. But the social cost is high, demanding urgent reskilling and upskilling programs. Future construction jobs will require technical expertise, not physical strength. Without intervention, automation could widen economic inequality, leaving many behind. Policymakers must ensure the transition is fair, with strong safety nets and new opportunities. Experts are divided on the rise of automated construction. Engineers hail the benefits, quality, speed, and safety. Economists and labor advocates warn of social disruption and job loss. There are also concerns about the reliability and safety of fully autonomous systems. Many agree the future lies in human-robot collaboration, humans supervising, troubleshooting, and making strategic decisions. This human-in-the-loop model could balance progress with job security. The debate is not just about what technology can do, but how we choose to use it. The rewards of automated construction are clear: faster, higher quality projects, and safer work sites. Economic savings and rapid infrastructure development can drive growth worldwide. Removing humans from hazardous tasks makes construction far safer. But the risks are real. over-reliance on complex technology, vulnerability to cyber attacks, and potential for catastrophic failures. The greatest risk is social. Mass job displacement without a plan could spark unrest. Policymakers must balance efficiency with social responsibility. The success of this transition depends on both technical brilliance and wise leadership. The future of infrastructure will be shaped by how we manage these risks and rewards. China's robot-built highway marks the dawn of a new era in construction, one that is rapidly transforming the very foundations of how we design, build, and maintain our infrastructure. This is not just a technological milestone, but a signal that the future of construction is arriving faster than anyone could have predicted. Full-scale automation is now a practical reality, with intelligent machines and autonomous vehicles taking on tasks once thought possible only for skilled human hands. These robots work tirelessly, day and night, assembling roads, bridges, and buildings with precision and speed that far surpass traditional methods. This shift is forcing us to fundamentally rethink how we build our world, and what roles humans will play in this new landscape. The potential is vast. Imagine infrastructure projects completed in a fraction of the time, with fewer accidents and less environmental impact. Automated systems can operate in hazardous or remote locations, building safer, more sustainable roads and structures, even in the most extreme environments. This technology could revolutionize how we connect communities and respond to urgent needs. But with this progress comes profound disruption. The impact on the workforce is significant, as traditional construction jobs are replaced or transformed by automation. This shift demands a societal response as sweeping as the Industrial Revolution, challenging us to support workers in transition and ensure that no one is left behind. To navigate this transformation, we must create new frameworks for education, safety, and ethics. Training the next generation of engineers, builders, and technicians will require a focus on robotics, artificial intelligence, and human-machine collaboration. We must also establish clear guidelines to ensure that these technologies are used responsibly and safely. The choices we make now, about who benefits, who is protected, and how we share the rewards, will determine whether this new era brings shared prosperity or deep divides. It is up to us to ensure that the benefits of automation reach everyone, not just a select few. Ultimately, the true test of this new era is not in the machines we build, but in our ability to build a future where humans and robots thrive together, creating a world that is safer, more efficient, and more inclusive for all.